Hey there, Luke here. Just here to show the assembly of the Neustruder and kind of talk about it a little bit. So this is something that I designed to be almost completely printable at home and have similar performance with both flexible filaments like TPU and NinjaFlex and that kind of stuff, as well as the regular filaments such as PLA, ABS, PETG, HIPS, that kind of stuff. I've printed nylons with this. I've printed just about everything. Alright, so I just want to have an assembly video and kind of talk through why the Neustruder is pretty good. Here we go. The printed parts that you're going to need are the bottom block right here, this large piece, bread and butter of the assembly, if you will. The top block right here, and then a small printed axle. And then for the purchase parts, you're going to have 3 M3 35mm screws, 3 M3 nuts, 2 M3 10mm screws, a bearing, and then the stock gear, which I've left on here. This motor is not the stock motor, which isn't that big of a deal. It's just that this is easier to do demos on because it's, not on my machine. Anyways, you're also going to need the Allen keys that correspond to the sizes on the M3 nuts. Should be pretty obvious which ones they are. Anyways, to begin, all you need to do is put the bottom block on the motor first. Make sure that these two holes line up with this connector. If not, your motor is going to be at an oddball angle where you can't get the connectors to work, so make sure that it's lined up with the connectors when you install it. And then you're just going to put the 2 10mm M3 screws into the holes and drive them in. Should be pretty simple to do. While we're driving in these screws, I want to talk about gear placement. The gear should have, this is the stock brass gear. This should also work for the 40-tooth stainless steel gear. But the non-tooth edge should be facing outwards, but it should be about in a stock location. Everything about the filament path through is the stock, so it will be feeding straight into the hot end. No curlicues, no different routes, nothing. It should be just straight through. Fairly easy. Then, after these two screws are on, you're going to take the axle, put it through the bearing, and then put it into the upper block. This should just push in. It's a fairly snug fit. The inaccuracies in 3D printing should actually help that quite a bit, just to make it easy. Sometimes it'll fall out. That's not a big deal, because the way that it works is it will be forced upwards by the filament as it drives against here, and so it'll do its job regardless. So that's not too big of a deal. Then all you need to do, put it on here, and make sure that the holes match up with the holes on the bottom. If it doesn't and it fits in, there will be quite a noticeable gap. So just make sure that it sits flush and that the holes line up. You should be good to go. Next, you want to put the 3 35mm screws in these holes right here. These holes are also used for tightening. So these will be used to tighten down and grip the filaments. So you'll loosen them and tighten them instead of having a lever arm forcing the filament against the gear. I prefer this because it allows for a much more granular control of tension. So for stuff that requires tension, you can really tighten it down. For stuff that doesn't, you can let it a little bit looser. It's infinitely adjustable, essentially. And then what you're going to want to do is you're going to take a nut and just thread it on, so it's just threaded. You don't need any more than that for initial installation. So all you're going to do, put those in those holes. It should only go in one way, and once it grips, it should stay that way. They shouldn't spin. you're not going to be putting so much force on these things in the torquing direction that they should break loose if they're holding, but just make sure that they're not spinning, because then they won't provide, or you won't be able to tighten them down, which is the whole point of them. So when you're done, there should be a little space in between. There could be none, there could be some, but as long as it's not like tight, or if you have space in the screws like this, yeah, there you go, a bit bigger gap, you should be good to go. And that is the fully assembled regular block. For filament, all you need to do is stick it in the hole and run it through. Right now it's tight enough that it's not going to want to go down. So if I take this pliers right here and start twisting it, it should start driving. And lo and behold, so this is TPU, right? I'm spinning it and it is driving through, no issues, and I haven't even tightened it down yet. I can pull this. Once I pull it, it still brings the motor along. I'm not sure if you can see that, but it is bringing the gear with it. So there you have it. The reason that the Neustruder works is because there is no room for the filament to flex in between the bearing and the gear before it exits onto the hot end. There is no room for it to go anywhere. I've had excellent success with it. There's another video on my channel that is 10 minutes of it printing, 2 prints with PLA. It's actually going to print the 2 things I use in this tutorial, as well as a benchy out of this TPU material. So there you have it. For the Mark 7 model, so this is a Mark 7 model, it has a bit bigger opening than the regular model, and that's because of the diameter difference between this and the Mark 7. So the reason it's like this is there is little itsy bitsy things that help guide the filament and make sure that there's no wiggle room in a hobbed gear. So then you force the gear in here, it feeds through just like it before, but you get the benefit of the hobbed gear, which can provide a lot more grip on many filaments. I personally prefer the Mark 7 gears. This is actually a hyena gear, which is a bit more aggressive of a bite, but I just prefer that. And the only difference between this and this in terms of assembly is that instead of having 3 screws in the base, you just have 2. So you eliminate this one. It works perfectly fine. It works identically without it. And again, I personally prefer the Mark 7 variant. And another thing that I forgot to mention earlier is to tighten it down. All you need to do is just screw in one of them till it starts extruding, and then screw in the others to just pass the tension of the first one. And then when you're done with that, you just screw in the first one to match that tension. And that's all you need to do to tighten it while it's on the machine to extrude filament correctly. It's very simple. To take it out, all you need to do is unscrew it, and you should be able to pull the filament out, just pull it straight out without any problems. I've even cut this part out, so now this is open. In previous versions it wasn't open, so that you can take a small screwdriver and pry up this block once these screws are loose, so that you have an even easier time of removing the filament if you so choose. Feel free to comment on here or on Thingiverse. I'm going to link in the description that has this to tell me your feedback. If anyone's made it and they're having problems, let me know. I'm here to help, and I'm here to develop for it. This should work for Prusa's that use the Mark 10 to Mark 8 thing, Creator Pros, Maker Slacks, Wanhouse, pretty much anything that uses that Mark 10 or Mark 8 extruder direct drive setup. This should work for, and this should do very, very well. So I look forward to having your feedback, and I hope this really helps. Bye-bye.